Hi Andy. Today, how to solve a pair of linear equations in two variables. I think everyone knows we have different methods to solve the pair of linear equation in two variables. One of the method is elimination method, substitution method, and cross multiplication method. But today I have taken a different type of equations. Let us see, especially x coefficients and y coefficients are numerically large. And one more interesting thing also is there. X coefficient of first equation is equal to y coefficient in the second equation, and y coefficient of first equation is equal to x coefficient in the second equation. When you get such type of equations, so already we know in the elimination method even we need to get equal coefficients of at least one variable. For example, 2x minus 3y is equal to 5, or 5x plus 5y is equal to 7 something, 7 I get. But here we need to get equal coefficients at least of one variable. Then only we can cancel that variable. Then only we can eliminate that variable. Then so that we can find out the value of other variable. But here they are not equal. When we are not getting equal coefficients, then we make them equal. How to make them equal? We can multiply any equation by any one constant. For example, here 2 and 5. 2 is not a multiple of 5. We never get 2 in the fifth table. 5 is not a multiple of 2. We never get 5 in second table. Then in that case, I multiply first equation by 5 and second equation by 5. So first equation by 5, second equation by 2. Why? Because if I multiply first equation by 5, I get 10x here. The same way if I multiply second equation by 2, I get 5 2's 10x, so that I get equal coefficients. So that I can cancel by subtracting or adding, I can cancel that x variable so that we find y value. But here if I follow the method, is it possible 217 is not a multiple of 131, 131 is not a multiple of 217. So to make them equal, I need to multiply first equation by 131, second equation by 217. Is it possible? Even it is possible, it will be tedious. I am sure it will take a long time also, because 137, 217 are numerically large. So that's why we use a smart method. What is that smart method? Smart method. Don't try to make them equal. So nothing will happen. Even x coefficients are not equal, y coefficients are not equal. Just you try to add them. We have an advantage. I am going to use that advantage. What is that advantage? Here the same coefficients are there in both equations but not in the same order. So x coefficient of first equation equal to y coefficient in the second equation. Y coefficient of first equation equal to x coefficient in the second equation. That is an advantage to us. Let us see how to use that advantage. I want to add them just. 217x plus 131y is equal to 913. 131x plus 217y is equal to 827. Let us see what happens if I add these two equations. By adding it, I think 348x, and by adding it 348y, and here 10, 4 and 1740. And is there any common factor is there for the coefficient? You can divide by that common factor on both sides. Of course, 174 2s are 348 table directly. 348 ones are 348 ones are. So is there any chance to get 1740 and 340? Of course we get, no doubt. You just take a trial. I am going to multiply it because the last digit is 0. I want to multiply by 5. Why? Because the 5 8s are 40 and the last digit 0 is going to get. That's why I am going to try directly. 340 5s are. 5 8s are 40, 5 4s 20 plus 4 24, 5 3s 15 plus 2 17. Yes, I am getting 1740. So 348. 5s are 1740. So finally I got the equation here. X plus y is equal to 5, which is a simplified equation. Now what to do? Simple. You put it aside here. So x plus y is equal to 5. Take it as a third equation by adding 1 and 2. Now I want to same equations. I want to subtract the equations. 217x minus plus 131y is equal to 913. 131x plus 217y is equal to 827. In previous case, I tried to add. So here in the previous case I added, I got one equation. Now I am going to subtract. What happens if I subtract one equation from the another equation? Don't forget to change the symbols of the second equation, every term, symbol of the every term of the second equation, because so that minus belongs to every term of the second equation. When you multiply a symbol by minus, automatically we get a different sign. Minus into plus, it becomes minus. Minus into minus becomes plus. So that when you are subtracting a equation from any one equation, simply you change the symbol of each and every term of the second equation. So that I can now 217 minus 131, how much? 7 minus 1, 6. Take the borrow, 11 minus 3, 8. So it will be 86x. The same here, 131 minus 217. You know, it's not plus symbol now. I change it as minus, and higher value has minus symbol, minus. I am sure you get 86y. And what happens if I subtract 827 from 913? Take the borrow, 13 minus 7, 6. And here will be 10. Take the borrow, 10 minus 2, 8. Of course, I get 86. Clearly, every coefficient is a multiple of 86. We can divide by 86 on both sides. 86 ones are, 86 ones are, 86 ones are. So finally, I got x minus y is equal to 1. I got one more equation. So x minus y is equal to 1. It is a fourth equation. By adding these two equations, here we got two other simple equations. Now try to solve them. I am sure you can find out the x value and y value which are satisfying the given pair of linear equations. Now let me solve it. X plus y is equal to 5. X minus y is equal to 1. Directly we are adding plus y minus y cancel because y minus y 0. X plus x 2x, 5 plus 1 6. So that x is equal to 6 by 2. So x is equal to 3. So we eliminated y. We got the chance to eliminate y because y both are same, equal coefficients. No coefficient means 1. Y minus y equal to 0. Now substitute x is equal to 3 in any one equation to get y. I am going to take the third equation, x plus y is equal to 5. And here 3 plus y is equal to 5. Y is equal to 5 minus 3. So finally y is equal to 2. It is a way to solve the pair of linear equations, especially when the x coefficients or y coefficients are numerically large and they are and same coefficients we get in both equations irrespective of the order. But maybe x coefficient is equal to y coefficient in the second equation and y coefficient of first equation equal to x coefficient second equation, in that manner. Then use this method to solve x and y. I want to check also whether it is right or not. Simple. Take and x value, y value in the left hand side of the first equation and check it whether we are getting RHS. Look here, our x value is 3. 217 3s are. 217 x means 217 3s are. 3 7s are 21. 3 1s are 3 plus 2 6. 3 2 6 61. And 131 y. Your y value 2. 131 into 2. You get 2 2 3s are 6. 2 1s are. You will let us add it. Let us see whether we get 913 on. Of course, we are getting here. So 900. Sorry. So 3 and it is sorry, let me check it once. 130, 3 7s are 21, 3 1s are 3, 3 plus 2 5, 3 2s are 6. So now add it. 1 plus 2 3 and 5 plus 6 11, 6 plus 2 plus 1 9. Yes, I am getting 913. Even you substitute same values in the second equation also, of course it will be satisfied by, we get 827. So it's an interesting method, one smart method, how to solve a pair of linear equations, especially coefficients are numerically large and the same coefficients we get in the second equation also, but they are not equal to same x and y. So thank you.